Hey everyone, welcome to another lecture of linear regression. And our today's topic is MLR, multivariate linear regression. And we have actually completed the gradient descent, and we have actually covered the examples for it, that how actually gradient descent works. Okay, using the examples and how does it work behind the code. Okay, actually we have done this. If you haven't watched that video or lecture, then you can get the video in the description. I think I would pin the video in the comment or whatever. But yeah, you'll get all the links below. Now, so today's topic is MLR, multivariate linear regression. Now, earlier, what we have seen actually, that we had only a data. We used to have a data in which we had y and x. Okay, sorry, x and y. And what we has to do, that what we had to do actually, that we had to, we had a function called as hypothesis, and in which we had beta 0, okay, plus beta 1 x1, sorry, x only, not x1. So what we used to do, that we used to put x into it, okay, into the function. We used to get our y hat, the predicted value, and we had only one, okay, we had only one variable to predict, okay. But now we have multiple variables, okay, we have multiples y, we would have a multiples y, or uh, value to predict. Now, first of all, let's get some of the terminologies for it. So all the x that you are seeing here are called features. Okay, why? Because these are the features that we'll use to actually predict our the model's prediction. Okay, that will be used for predicting, the point or the data. Okay, the pointing this, and the y, it is actually called the label. Okay, in the machine learning terminology, what we call it, a label. Okay, so we will use features to predict the label. Okay, and so what we will do here is actually, okay, if I write it, then as you know that this is features and these are labels. Okay, or label. Now, before that, we used to build a function that is nothing but hypothesis function. We used to do beta 0 plus beta 1x. Now we have, more uh, more variables right now, more features. So what we will do actually is that we will use, it will be same, we will give x, okay, but not every time x. We're not giving only a single x, okay. So we'll actually giving the hypothesis all the features, okay, all the features. And in the features, what we have, beta 0 plus beta 1 x till, will go till beta p xp. I'll explain you what it is actually. I will definitely explain you what it is, okay. Now, what we are actually uh, doing here is, okay, what we are actually doing here is that we are using all our features to predict our y, okay. We are using all our features to predict our y. So what we're doing here is actually, earlier we used to give only one x, we used to give to our hypothesis function, and it used to give us our y. But now we have multiple x, okay, or features, okay. And now we'll give our hypothesis function this, okay, we'll give our hypothesis function all the x's, and it will give us our y, the predicted y, okay. And what this function looks like, what this function actually looks like, it looks like beta 0 plus beta 1 x1, okay, beta 1 x2, beta 2 x2, then beta 3 x3, okay, till beta n xn, okay, beta n xn. This is how our functions looks like. And if you want to actually generalize it, that how it actually looks, then we could say it looks like sigma, uh, it looks like sigma from 0 to n beta I xi, okay. This is our hypothesis function in which we are giving our x, okay, and we are getting our y, okay, we are getting our y. This is our the generalized form, this is our generalized form. Now let's see some of the things that I've prepared for you actually is that C. Yeah. So what we have here is we have our X and Y. Okay. X is all the features and Y is the labels. Okay. Now understand what it is actually. Okay. So we have been given a data in the table. Okay. It is actually a table. Okay. This is this because it is kind of a tabular form. Now we have some number of rows here. Okay. And we have some number of columns here. Okay. How many rows do we have? We have one row, two row, three row, and all the rows till n. Okay, till n. How many columns do we have? We have one column, two column, three column, four, five, six, and many till p column. Okay, and what is the size of this table? And if you see very specifically, then what we can say that it is not a table, but it is actually a matrix. It is actually a matrix. Okay, which the size of the matrix is n into p. Okay, n into p, n into p, where n is nothing but the rows. Okay, the number of rows, and p is the number of columns. Okay, this is the column. Now what are these 1 1 1 2 1 3? This is nothing but the position of the data. This is nothing but the position of data. Okay, so as we know that we use this for showing the row and this for showing the column. Now this data, this I would say this example, okay, this sample example, this is in the first row and the first column. Okay, this is what is saying, and this is in the uh, first row and the second column. This is in the first row, third column, and this is how it looks. So we have p columns. We have p columns in which we have first our first row, but we have p columns. Okay, and for the same like this, we have second row, first column, second row, third column, second row, third column, second row, second column, and like this till p. And we have how many rows do we have? We have n rows and p columns. Okay, now for same that we have y. Okay, we have labels. What our labels is actually y1, y2, y3 till n, till n. And what is the size of it is nothing but n into 1. Okay, the number of rows into the number of column. What is the number of column here? The number of columns we have 1. Okay, and the number of rows is nothing but n. Okay, is n. Now as I've shown you, as we have uh, get to a conclusion that how will we find it. So this is actually how our hypothesis function looks like. This is how our hypothesis function looks like, which is like this. So what we are doing actually is that we are using our betas, okay, the weights, okay, our betas or weights to actually predict. And how we are doing it? We are using our beta 0, beta 1, xi1, 1. Okay, what is actually? So we have generalized this formula, and what we are, if you see very specifically, then you will see that only our rows are changing. Okay, 1 2, the column will be same. Okay, suppose that if we are using this row, the column will be same. Are you getting it? The column will be always same. How the column will change? The number of column do we have? Okay, and if you choose this data, okay, this data, if I tell you, then suppose that we have x1, x2, x3, x4. Okay, and we have data till x2, x3, x4, and x5. Okay, and suppose this is this. Okay, and we have this. And if you see actually, then in the every row, okay, in the every row we have 5 rows, and in the every row we have actually 4 columns. Okay, 1 2 3 4. Then how can the column change? Column cannot change. Okay, the number of column cannot change, because if we pick this row, the first row, we will have x1, x2, x3, and x4. Same, and if you pick also this row, we will have, okay, x2. Okay, suppose the number, forget the number. Suppose it will something x3, x4. Forget the number. Okay, actually understand what I'm trying to say. So this is, we have always have 4 columns, and the number of rows can be changed, but the number of column won't change. Okay, and this is what we have generalized here. What we have done this, that I, okay, I is to rows. It can be first row, second row, third row, fourth row, fifth row, any row. It can be this row, this row, this row, this row, this whatever. Okay, it can be anything, but the column will be always same for one. Okay, so that's how we have generalized this thing, and we said and we told that yeah, this is how it will look like. Now we will actually see that how we are multiplying it. Okay, we are doing it, but how we are actually doing it, because we believe in seeing everything. How is it being done? Okay, so now what we did actually is that, let's see. So suppose that first of all we had the first matrix, okay, of our features, and we have the second matrix. We can say it a matrix because it has only one column, so we can say it called a matrix, but it is actually a vector. But we can say it that it is actually a matrix, suppose that, which has n rows and one column. Okay, we have this. Now what we want, y hat, we want this, our predicted value. So for that we need to multiply our betas and x's, all those. Okay, so what we did here actually is that we got our betas. Okay, we got the matrix of our betas. Okay, or the vector of our betas. So suppose that we say vector, but for now let's say it column. Okay, so we got our betas. Okay, and what we did here is actually is that, so we know that we have one beta that is actually not with, that is not actually multiplied with any x. Okay, that is not actually multiplied with any x, which is this beta 0, which is this beta 0. Okay, this is not actually multiplied with any of it. So what we did here actually, we did some manipulation and we added one more column of only one, of only one. Why? Because we had beta 0 also, and we have to take care of this, that this beta will be also multiplied with this. Okay, this beta will be also multiplied with this, so we need to take care of this beta also. So what we did, that we added a column only of one, so one won't change our output, because anything multiplied with one will be result, the result will be itself. Okay, so what we did, we got our the betas. Okay, and we got this row, and we multiplied this, and we multiplied this. If you don't know how the matrix multiplication works, then you can find, and you can go and search on the internet. It's a simple, man, it is very simple. You can go and watch on the YouTube how the matrix multiplication is done. I'm not going to tell you, but I will show actually that how we do it. Okay, how we do it. So we picked this row, and we picked our whole betas and we multiplied it, and how we did element wise. Okay, we did element wise like this, and we got our all the x's and all the betas. Okay, and what we got the result our is nothing but the y hat 1. Okay, why, what is y hat 1? Y hat 1 is nothing but the product, the sum of products. Okay, we did all the product of betas and x, and we did its sum. Okay, and what we got, our y hat 2, y hat 3, like that we have got all our y hats. Okay, and we built, and we not built, and we got our another vector or matrix for y hat. Okay, okay, now let's see it by example that how we do it. So suppose we had the x column. Okay, so we had this x1, x2, uh, this, then we have another x1, x2. Okay, in the rows. Okay, in the rows. So this we have the beta 0, beta 1, beta 1, beta 2. Okay, so what we did a new thing, is that in the matrix 1 1, x1, x2, x1, x2. Okay, and we had our beta 0, beta 1, beta 2. Okay, now we did our multiplication, this with this, this with this, this with this. So pick this, we picked this. Okay, so now pick it. So we picked actually this first and we picked this. Okay, now we'll multiply it. So 1 into beta 0 plus x1 into beta 1. Okay, we can do it also. It's multiplication, man. We cannot. Why cannot we? X2, beta 2. We got it our first y hat. Okay. Now for the another y hat, we had did the same. Okay. The number is same, but the data is not actually same. Okay. So beta 0 plus x1, beta 1 plus x2, beta 2. So can you see actually that adding one made us so easy that we can add, okay, we can actually add our beta 0 actually. So this is why we add 1 to it. This is why we add 1 to our uh, this features column. Okay, features in the data in the another column of 1 in our features. Okay, and that's how we got our that's how we got our y hats. Okay, all the y hats. Okay, so this is how we did it. Okay, now we are done with what we used to do earlier. We are done with prediction. Okay, now we have to got our cost function or error. Okay, now we have to deal with our cost function or error. That what is the error actually is. So what is our the original value y, and what is our predicted value y hat. Okay, y hat. So we need to find this because we also need to minimize it our error because we need actually minimum to minimum error. Okay, so uh, what we did here actually is, okay, what we did here is that we had our y hat, which is this. Okay, and we did actually is that something known as e, which is nothing but error. Okay, error. What we did that for every, okay, for every we had y1, so we did y hat minus 1, y2, y hat y hat 2. Okay, y3 for every samples of the data we did like this and we named it error. Okay, we named this uh, we named this vector or matrix as error. Okay, error. So we will get our error. We'll get our error. Okay, so for that, okay, for that, can we change this to x into b, x into by? Cause what is this actually? What is this? If you see, this is or this is, it is nothing but the multiple of x into beta, x into beta. Okay, so can we name it our y hat x into beta, x into beta? Can we name it? Yeah, definitely. Okay, definitely. So what we did actually is that like this x beta. Okay, and for the every for the every data we did it. Okay, now we got our error. Now we got our error. Now if we got our error, then we will square it. We will square it. So what we are doing is we are actually, if we are squaring this, then we are actually squaring the every element in it. Okay, y1 x beta. Okay, this x beta this. Okay, we are doing it. Got it? For the every data we are doing it. Okay, got it? So we are squaring it, and if we square it, then what it will be? It will be nothing but MSE, mean squared error. It will be nothing but mean squared error. Okay. And now we have to minimize our mean square error. Okay. We have to minimize our mean square error. Got it? Are you getting it? What I'm trying to say? So what we have right now. So we have to minimize our this, and what we'll use it. As you know, guess it. What we'll use it? Gradient descent. Gradient descent. We'll use gradient descent for minimizing our this error. And what is the gradient descent for it? Here we have a different, like form. Just so before that we had the gradient descent. Okay, something different, and now we have something different. So we'll do this. Okay, and for this we'll do this, or you could say x into beta minus y. Okay, and transpose of it into x into beta y. Okay, not transpose of it. Okay, yeah. So what we're doing, that we're multiplying the same. Okay, we are doing this and this, but what we're doing, we're just using the transpose of what is the transpose? Transpose is nothing but changing rows into the column, changing rows into the column. So what will, suppose that we have a matrix like this, 1 2 3 4, and if we transpose this matrix, we have A. Okay, we have a matrix A, and if we do the transpose of the matrix, then it will be this will come here, and this will come here. So what it will be? It will be 1 2 3 4. Okay, see, it was actually a column, it became a row. It was a column, it became a row. It was a row, it became a column. It was a row, it became a column. Okay, and that's how we will do it. Okay, so I hope, guys, that you would have no issue or error, not error, doubt it right now. So if you have any problem, then you could ask me in the comment, and you could join our Discord also. You'll find more enthusiasm about AI and ML there also. So thanks for watching till right now. Bye bye.